Before you look at the machine, look at what the ground has to carry. More than 31 million pounds of steel, tracks, massive buckets, corridors, and entire command rooms, stacked into a machine 315 feet tall and stretched across 738 feet of mine floor. A normal vehicle needs a road. This thing needs a landscape willing to surrender. At the end of this lineup is a colossal machine with 18 buckets locked onto a rotating wheel, stripping up to 8.5 million cubic feet of earth per day. But before we reach it, the scale climbs. Through coal haulers, superdozers, mining trucks, electric shovels, and tunnel machines, built so large they stop feeling like equipment, they start feeling like moving land. The first machine does not try to look elegant. It was built for coal, weight, and punishment. The Kress 200C3 coal hauler is 43 feet long, nearly 16 feet tall, and weighs about 200,000 pounds before a single load touches the bed. Fully loaded, it can carry more than 400,000 pounds of coal. That is not a delivery run. That is a moving wall of black inventory. Under the metal is a Caterpillar 3516C diesel engine, producing up to 2,100 horsepower gross, forcing the machine up mine inclines where normal trucks would start begging for mercy. The curved dump bed is not decoration. It is there to swallow more coal per trip and turn the mine into a tighter, meaner logistics machine. The tires stand about 10 feet tall, stand beside one, and all sense of human scale vanishes. It feels less like a vehicle and more like a steel building with a cab bolted to the side. This is the entry point, a brutal one. But it only carries the mine. The next machine starts pushing the mine out of its way. A normal bulldozer reshapes a job site. The Komatsu D575A-3SD attacks the ground like it owns the deed. It stretches 38 feet long, stands 16 feet tall, and carries a 23-foot blade across its front. That blade is the whole insult. It's wider than a small storefront, and it does not ask dirt to move. It orders it gone. The machine weighs more than 335,000 pounds. Its V12 engine produces 1,150 horsepower, all built for low-speed authority, not speed, not style. Torque, the kind that lets a steel wall push up to 90 cubic yards of material in a single pass. That is the fingerprint of this machine. One pass. A smaller dozer has to work the ground. This one humiliates it. The crawler tracks spread the weight. The rigid suspension holds the machine steady, and the blade turns rough mining terrain into something closer to submission. But pushing earth is still surface-level violence. The next machine does not push the ground aside. It reaches into the pit, lifts the earth by the bucket, and feeds it into trucks. The Hitachi EX8000-6 is what happens when an excavator stops being a tool and becomes a mining system with an arm. In loading shovel form, it weighs more than 1.8 million pounds. Its cab structure sits over 32 feet high, but when the front end reaches up, the working height climbs past 67 feet. That matters because this machine is not just sitting there looking large. It is cycling through rock, dirt, and ore with the rhythm of a factory press. Two Cummins diesel engines produce a combined 3,880 horsepower. The loading shovel bucket carries more than 56 cubic yards of material. One bite from that bucket can move the kind of volume that makes a pickup bed look like a kitchen drawer. Do not picture a bucket. Picture an open steel room hanging from a hydraulic arm. The cabin is enclosed, climate-controlled, sound-insulated, and fitted with digital controls, because the operator is not driving in the normal sense. He is commanding a hydraulic animal built to feed ultra-class mining trucks in only a handful of passes. That is the violence here. Compression of time. What smaller equipment handles in long cycles, the EX8000-6 reduces to a few deliberate bites. In copper, gold, and coal mines, that is not convenience. That is money, time, and terrain being forced into obedience. And once a machine can feed trucks at that scale, the next question is obvious. What kind of truck deserves to stand underneath it? The Caterpillar 797F is not a dump truck in any normal American sense. It is a private freight system for a mine. The machine is 49 feet long, 23 feet tall, and almost 33 feet wide with the mirrors out. Empty, it already weighs more than 575,000 pounds. Load the bed with up to 400 tons of material, and the total machine mass climbs beyond 1.5 million pounds. The tires are nearly 13 feet tall. Before you look at the bed, before you look at the cab, look at the tire. It is almost twice the height of a standard American garage door. That is the scale warning. Then comes the mechanical arrogance. A Caterpillar 520 produces 4,000 horsepower tied to a 7-speed planetary power shift transmission built for loaded climbs, brutal grades, and controlled descents. This is old-school mechanical dominance, scaled until it becomes almost obscene. And stopping it is its own engineering problem. The 797F uses forced oil-cooled, multiple disc brakes on all 4 wheels, continuously cooled through a water-to-oil heat exchanger. That is what it takes when more than 1.5 million pounds of machine and payload start coming downhill, and gravity decides to collect. A regular dump truck moves dirt. This machine removes the need for ordinary thinking. It works in iron, copper, and coal mines, where braking systems and suspension are not comfort features. They are survival systems. Every loaded descent is a negotiation between weight, gravity, oil, and steel. But mass can be made stranger. The next truck takes the same basic job, then throws away the purely mechanical attitude. 2 diesel engines, electric wheel motors, a cab that looks almost misplaced on its own body. The Bucyrus 495HR does not prove power with speed. It proves power by standing almost still and making the mine come apart in front of it. This is an electric rope shovel, a high-voltage mining machine built around repetition, leverage, and punishment. In a typical 60 cubic yard dipper configuration, the machine weighs nearly 2.7 million pounds. That is not a vehicle weight. That is a building foundation with crawler tracks underneath it. The dipper is the signature. Not a bucket. A dipper. A steel mouth built to carry 110 tons of material, with available payloads reaching up to 120 tons depending on the setup. In the right loading cycle, a 495HR can help fill a 400-ton haul truck in only 4 passes. That is not brute size for display. That is scheduling violence. High-voltage power feeds the shovel. Electric systems drive the hoist, the crowd, and the swing. The ropes lift the dipper. The revolving frame turns the body. The machine does not chase the material. It forces the material to come through its cycle. Its entire empire is built on one cold rhythm: lift, swing, dump, repeat. The operator sits above the work, not beside it, looking down over a machine that turns overburden into a timing problem. Every pass removes another section of ground from the argument. And that is the purpose of the 495HR. It does not need to roam across the mine like a truck. It owns one position, attacks from there, and feeds the haulers that keep the operation alive. But the 495HR is not the end of the electric shovel bloodline. It is the old throne. The next machine takes the same basic ritual, lift, swing, dump, repeat, and turns it into a 3-pass execution built for 400-ton trucks. The BelAZ 75710 looks wrong because the human brain still wants to call it a truck. It is 67.5 feet long, 26.5 feet tall, and 32 feet wide. Empty, it weighs around 793,000 pounds. Loaded, it can carry up to 992,000 pounds of material. That payload is the crown. The 75710 was built around a 450-ton class payload. During testing, it hauled more than 1.1 million pounds, 555 tons in a single run, enough to put BelAZ into the Guinness record books. That is the moment where large truck stops being a category and starts sounding like an insult. The machine uses 2 V16 diesel engines producing a combined 4,600 horsepower. But unlike the Caterpillar's old-school mechanical attitude, this one sends power through a diesel-electric system. The engines feed generators. The generators feed electric wheel motors. The truck does not simply drive. It distributes force. And visually, this thing is a freak show in steel. It rides on 8 massive tires, 4 in the front and 4 in the rear. The axle system lets the truck bend through a turn with a kind of slow, hydraulic arrogance. When the tires start steering together, the body looks too large to be obeying the road beneath it. The cab sits on the side, almost swallowed by the body around it. The fuel tank holds more than 1,300 gallons, not as a convenience but as an industrial reservoir for a machine with its own appetite. In open-pit mines, the BelAZ 75710 exists for one reason: fewer trips, heavier loads, less tolerance for anything small. But roads and mines are still open air. The next machine takes industrial scale underground, beneath traffic, buildings, utilities, and the nervous system of a major American city. Bertha was not built to cross a landscape. It was built to disappear under one. The SR-99 tunnel boring machine measured 57.5 feet in diameter, stretched 326 feet long, and weighed nearly 7,000 tons. Under downtown Seattle, that is not just a machine. That is an underground factory with a circular steel face almost as tall as a 5-story building. Hitachi Zosen built it for one of the most unforgiving jobs in American infrastructure: carve a new highway tunnel beneath a living city. Bertha commanded a 25,000 horsepower power system. The cutter head chewed into soil, clay, rock, and concrete, while hydraulic thrust cylinders forced the machine forward, inch by inch. Behind the cutting face, conveyors, control rooms, electrical systems, ventilation, and crew workspaces turned the machine into a self-contained industrial throat. The contradiction is almost obscene. Above it, Seattle kept pretending to function. Buildings stood, traffic moved, utilities stayed buried in the danger zone. Below it, Bertha was manufacturing a 1.7-mile highway tunnel, removing earth and installing reinforced concrete segments as it advanced. That is not digging. That is building a road inside the ground, and then the ground fought back. After roughly 1,000 feet of progress, Bertha overheated and stopped. Not for a day. Not for a bad weekend. The machine sat trapped underground while crews opened a 120-foot deep rescue shaft from the surface, reached the front of the machine, and lifted the cutter head out for repair. That is the nightmare of a mega machine. When it fails, you do not tow it away. You excavate the city to reach it. Bertha eventually resumed tunneling, finished the dig in 2017, and was dismantled after the job. But the real image is not the completion date. It is the rescue operation, an $80 million machine buried under Seattle, waiting for the surface to come down and save it. Then the scale returns to the mine, not with a tunnel machine, but with an electric shovel so large it starts to resemble a refinery that learned how to dig. The Komatsu P and H4800XPC is what happens when an electric rope shovel stops competing with trucks and starts controlling their schedule. It is not here to look heavier than the old machines. It is here to make the loading cycle shorter, colder, and more expensive to ignore. Its operational weight lands at precisely 3,648,924 pounds. That puts more than 3.6 million pounds of electric mining hardware on crawler tracks before the dipper even bites into the bank. This is not a shovel in the backyard sense. This is a loading platform built large enough to dictate the rhythm of an entire pit. The dipper capacity runs from 86 to 92 cubic yards. The rated payload is 135 short tons. That is the weapon. Not height, not spectacle. 3-pass loading. A 400-ton haul truck does not sit under this machine waiting for a long conversation. The 4800XPC is designed to fill ultra-class trucks in 3 passes. 1, 2, 3. The truck leaves, the schedule tightens, the mine gets less patient with smaller equipment. That is the difference between size and authority. High-voltage power feeds the shovel. A C-drive systems control the hoist, crowd, and swing. Adaptive controls manage the digging cycle with the kind of cold precision that keeps impact, loads down, and production up. The machine is not just stronger. It is smarter about where the force goes. Visually, it looks less like a vehicle and more like a power station with a mouth, a high-mounted cab, a massive revolving frame. Crawler tracks under a steel body heavy enough to make the ground feel rented, and unlike a truck, it does not need to travel far to dominate the mine. It only needs the right position. From there, the 4800XPC turns, loading into a command structure. The trucks arrive, the dipper swings, the payload lands, the truck disappears under 400 tons of consequence, but even this is still a disciplined machine. Fast, electric, repetitive, built for production. The next machine belongs to a rougher age, when engineers stopped trying to optimize the loading cycle and built a walking power plant to drag the earth away in one pull. Big Muskie sounds almost friendly. That is the first deception. The Bucyrus Erie 4250-W was a walking electric dragline built in 1969, and its numbers still feel like they came from an argument between engineers and gravity. It weighed more than 27 million pounds. The boom stretched 310 feet across the sky. With the boom lowered, the machine measured nearly 500 feet long. This was not a shovel parked in a mine. This was a steel landmark that learned how to walk. Big Muskie did not roll on wheels like a truck. It moved on giant walking shoes, slowly shifting its body across the Ohio coal fields. Every move was deliberate, heavy, and almost prehistoric, like the machine had to negotiate with the ground before taking another step. The bucket alone was an industrial event. It held 220 cubic yards of material. Fully loaded, one bite could carry 325 short tons of earth and rock. That is not a scoop. That is a building-sized wound being pulled out of the land by cable. More than 24,000 horsepower moved through the main drive motors, fed by a 13,800-volt electrical supply. The hoist, drag, and swing systems turned electricity into violence at a scale that still feels unreasonable today. Big Muskie tore through layers of soil and rock to strip away the overburden above Ohio coal seams. It did not clean the land, it opened it. In its working life, it moved hundreds of millions of cubic yards of earth, enough to make normal excavation sound like a clerical task. And then, after decades of work, most of the machine was cut apart. But the bucket survived. That bucket matters. It turns the machine from equipment into a monument, a public reminder that once someone built a walking power plant just to tear open the ground. And still, this is not the final scale. The boss of this lineup does not swing one bucket through the air. It uses a continuous wheel with 18 buckets, turning excavation from a single violent pull into a machine-made appetite that does not stop. The final machine in this lineup does not arrive like a vehicle. It arrives like a moving border, the Takraf Bagger. 293 is more than 700 feet long, rises over 300 feet tall, and weighs 31.3 million pounds. At that scale, the human body has no useful comparison left. A person beside it becomes a maintenance detail. A truck beside it becomes a prop. This is not just the largest machine in the lineup. Guinness World Records recognizes Bagger 293 as the largest land vehicle, the heaviest land vehicle, and the largest mobile industrial machine ever built. The record is not decoration, it is the verdict, and the power matches the verdict. Bagger 293 does not carry a normal engine room like a truck or a shovel. It commands 16.56 megawatts of externally supplied electricity, the American equivalent of more than 22,000 horsepower. That power does not exist for speed. It exists to keep a steel continent moving, cutting, conveying, and feeding itself without pause. But the power system is not the point. The point is the wheel. A bucket wheel nearly 70 feet across carries 18 buckets around its rim. Each rotation turns the front of the machine into a continuous mining weapon. Big Muskie pulled the earth away in one violent bite. Bagger 293 does something colder. It never has to stop biting. Bucket after bucket. Rotation after rotation. Earth lifted, transferred, conveyed, and turned into output. Together, the system can remove about 314,000 cubic yards of earth per day. That number is not a statistic. It is a daily act of territorial conversion. Bagger 293 is not designed around the rhythm of a single scoop. It is designed around continuous appetite. The wheel cuts, the conveyors carry, the structure advances. The mind does not receive individual strikes anymore. It receives a moving front. Inside the machine are technical rooms, maintenance corridors, equipment stations, and an elevated cockpit. That is why calling it a vehicle feels cheap. Vehicles have seats. This has internal infrastructure. The tracked undercarriages move the mass across the mine floor. Steering systems coordinate the crawl. Conveyor systems take the material away. The machine does not simply dig. It reorganizes the landscape into a supply chain. That is why it earns the final slot. Not because it looks impossible from a distance, but because the numbers survive contact. 31.3 million pounds. Over 22,000 horsepower, 18 buckets, about 314,000 cubic yards of earth per day. A Guinness record holder built so large that the phrase heavy equipment stops sounding serious. At this scale, machinery stops behaving like equipment. It becomes moving land. And that is the real story behind machines like these. They are not built because someone wanted something large. They are built because ordinary scale failed. A normal truck could not move enough. A normal shovel could not bite deep enough. A normal dozer could not push hard enough. A normal tunnel machine could not survive the pressure. So engineers kept adding weight, more steel, more power, more reach, more payload, more appetite, until the machine stopped feeling like equipment and started feeling like a decision made against the landscape. From coal haulers and superdozers to electric shovels, tunnel borers, walking drag lines, and bucket wheel giants, every machine in this lineup exists for the same reason: to make the ground obey a schedule. Some carry the mine, some cut into it, some drag it away, some turn it into a conveyor-fed supply chain. But the final lesson is simple. When mankind builds machines this large, the question is no longer what they can move. The question is, what can survive standing in their way?